Hey folks, moving on to chapter 7.6, number 340, solving rational inequalities. Okay, this one is going to be a little weird at first. Little weird. Okay. Remember the parentheses and brackets? I'm going to use open circles and closed circles. I find it easier for these types of problems. So first thing we need to do is look at the bottom, the denominator. Open circles for domain. This isn't going to make much sense, the first one we do. 0, 1, 2, 3, 4, 5. So remember we're talking about domain. You're not allowed to divide by 0. So let's make sure that x is never 5. So I set the bottom equal to 0. So first thing you do is set the bottom equal to 0 and figure out where all the open circles are going to go. So at 5, there's a big open circle. Our answer cannot be 5. Okay. And now the right side needs to be 0. So the problems start out pretty mellow because they keep giving us the right side 0. Do they give it not 0? Okay, they eventually make it not 0. So right now, the right side's 0, so we're good. So now, set the top equal to 0, or equal to. So when does the top equal 0? Negative 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Negative 6. Now, the question is, so the denominator always gets an open circle. Now, the top, depending on this symbol, will either be open circle or closed circle. Because of this underline, it could be equal to 0. I'm going to use closed circle. Oh my gosh. Okay. If that little bottom part was not there, I would have put an open circle right there, because open circle means it can't be equal to 0. But we're saying it might be equal to 0. So I'm going to say negative 6 would be equal to 0. Negative 6 plus 6 is 0, which is equal to 0. So closed circle. So the denominator is always going to get open circles. And then the top, depending on whether or not it's underlined or not, if it's an or equal to, will tell you whether or not, when you set the top equal to 0, if it gets open circle or closed circle. So far we have closed circle for the top. Already confusing. Okay. Just go along with it. The next one will make more sense. So now tell me if you see this. We call these things critical points. So there's this area, there's this area, and then there's that area. So there's the area to the left of that dot, between the dots, and to the right of the dot. There's 3 areas. So now we're just trying to figure out if this statement is true or false in each of these 3 sections. So mathematically, whatever we choose, whatever dot we choose between these 2 dots must all be the same, either all true or all false. So the easiest number to pick would be 0. So what if we plug 0 into this equation? Is it going to be true or false? 0 plus 6 is 6. 0 minus 5 is negative 5. So if I plug 0 in, it's basically 6 over negative 5, which is basically negative 6/5. Is a negative number more than 0? Is a negative number greater than or equal to 0? No. So 0 would give me false, which means this whole area between the dots must be false. So the 0 was my test point. These are my critical points or critical values. I think they're called critical points. And you need to choose something between. Choose what's easiest. 0 is usually the easiest. So this whole area is false. Now let's pick a number over here. So maybe we pick something like 6. So if I pick 6, that's going to be 12. And then 6 minus 5 is 1. 12 over 1 is 12. Is 12 greater than or equal to 0? Yes. So this whole area is true. Okay. Same game over here. Pick something to the left of this critical value. So maybe negative 7. So negative 7. If I plug in negative 7, that gives me negative 1 over negative 12. Negative 1 over negative 12. Negative over negative is positive. 1/12. Is 1/12 greater than or equal to 0? Yes. Whew. Okay. So now, based on this picture, we're going to write our answer in interval notation from left to right. So basically this area, everything up to -6, including it. So I would say from -infinity to -6, include the -6, bracket, solid dot, same, all the way to -infinity. And then also this area, remember, union. And now this area, open circle, parenthesis, 5, comma, all the way over, infinity. Oh my gosh. Okay. See how easy that was? Okay, let's try the next one, 342. Yeah, this is weird, but when you do the next one, you're like, okay, we're doing the same thing over and over again. So let's just save a piece of paper. 342. 342. X minus 4 all over x plus 2 less than or equal to 0. Number line 0. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, so first thing we do, the denominator. Set it equal to 0. X plus 2, set it equal to 0. That would give us -2. So at -2, open circle, because we're not allowed to be equal to -2. So the denominator always gets an open circle. Up top, open circle or closed circle. Oh, it's underlined. It's or equal to, so it's going to get a solid dot. What makes the top 0? +4. 1, 2, 3, 4. Okay. Now you should see the three areas. This area, that area. So we need to choose 3 test points. So between -2 and 4, the easiest is probably 0. So 0 minus 4 is -4. 0 plus 2 is 2. What's a -4 over +2? That's -2. Is -2 less than or equal to 0? -2 less than 0? Yes. This area is true. Okay, let's pick a number like 5. 5 minus 4 is 1. 5 plus 2 is 7. 1/7. Is 1/7 less than 0? No, it's positive 1/7. That's not less than 0. False. Let's try a negative number like -3. So -3 minus 4 is -7. -7 and -3 plus 2 is -1. -7 over a -1, that's positive. And I need to write it down. I plugged in -3. So up top, that would be -7. If I plug in -3, that's -1, which is 7. 7 less than 0? No, false. Okay. So the answer, we just need to tell the true, where it's true, so between those values. So from -2 to 4. Open circle, so parenthesis, closed circle, so bracket. Aha. Interesting. Okay. 3, 4, 4. X plus 8, x plus 3, greater than 0. Okay. So go to the denominator. That's always an open circle. So at -3, set the bottom equal to 0. -3, so 1, 2, 3, -3, open circle. Now up top, open circle or closed circle. It's not or equals to, so it's going to get a open circle. So go to -8. 4, 5, 6, 4, 5, 6, 8, -8. Open circle. Okay. And then now you should see 3 areas between the test points and outside them. Okay. Pick a number between -3 and -8. I don't know, -5. So if I put -5 in here, -5 would give me 3. -5 would give me -2. 3 over -2, that's a negative number. Is a negative number greater than 0? No. That area is false. Let's pick a number over here. So you might say, oh, we always just pick one over, like pick -2. You can pick any number you want. Why don't we pick 0? Isn't that one easier? Because you see how the 0 just becomes 8 over 3. Is 8 over 3 greater than 0? Yeah, 8/3. It's a positive number. It's greater than 0. This area is true. Over here, negative, You could pick -9, -10, -11, whatever's easiest. Let's pick -9. So if I put -9 in, that's -9 is -1, -9, -9. So negative over negative is positive. 1/6 is 1/6 greater than 0. 1/6 greater than 0. Yes, true. You'll notice that they keep alternating. True, false, true, false, true, false. If it's a simple problem, like this looks pretty simple, right? It's going to alternate. So later on we'll get things that don't alternate, but right now, because the problems are so simple, they coincidentally are alternating. Okay, so open circle. So from -infinity all the way to -8. Open circle is a parenthesis. We're also this area, so we use the union symbol. From -3, parenthesis on -3, all the way to infinity. Boom. And there's our answer. Oh, my lordies. In 349, the top, it says 6x. So when you set that to 0, what would be 0? 0. So if x is 0, that would be your critical point. X is 0. Okay, let's try. Let's see, is there a good one? Oh, jeez. Okay. 348. Did I out loud? 348. You see how it's equal to, or zeros on the right? That makes everything easy. So I'm looking at 348. And they do not have 0 on the right. It's 5x over x minus 2 less than 1. So we need to make the right side 0. So 5x over x minus 2 minus 1 less than 0. Okay. Now, I haven't done these in forever. Let's see. So then we do what? Okay. I snuck a peek at a sample problem. Okay, so now that's 1, so make it 1 over 1. Oh, we're going to need a common denominator. So this needs an x minus 2. This needs an x minus 2. So we have 5x minus x minus 2. I'm going to put parentheses. Minus 1. X minus 2. Does that look better? All over our x minus 2. It's less than 0. So that's going to be 5x and then distribute minus x plus 2, which is really just a 4x plus 2. If you factor that, that's a 2. X plus 2. I was just doing the numerator. So 2x plus 2 is just that numerator. So let's bring it all back over here. So this numerator, 5x minus 1 times x minus 2, I cleaned it up. It's just 2 times x plus 2 all over. Put that denominator back. Oh, this got confusing. This is less than 0. Okay, let's pause for a second. Had to bring the 1 over. Okay, common denominator. Okay, clean up that numerator. Okay, I did it here. And then so we're right here. Now we're back at this game. So you draw your little number line. 0, 1, 2, 3, 4, 1, 2, 3, 4. So the bottom always gets an open circle. So what makes the bottom 0? Positive 2. Open circle. The top, what makes the top 0? Negative 2. Open circle or closed circle? It's not underlined. Open circle. Okay. So now you should see this area, that area, like that. So 3 distinct areas. We need test points. The middle one, let's test 0. So if you plug 0 in here, that's a 2 times 2 is 4 over negative 2. 4 over negative 2 is negative 2. Is negative 2 less than 0? Yes. True. Let's pick a number over here like 3. So 3 plus 2 is 5 times 2. 10 over 1. 10 over 1 is 10. Is that less than 0? No. False. And this is probably false too because it's probably going to alternate because it seems pretty simple still. Let's try negative 3. negative 3. I kind of put my notes off to the side, so that's 2 times negative 3 plus 2 is a negative 1. Negative 3 is a minus 5. Negative over negative is positive. Positive can't be less than 0, so false. You see how I didn't even really figure out what the exact number was? It's what, 2/5? But I was like, oh, it's some positive number. A positive number can't be less than 0, so it must be false. So sometimes you can get a little bit lazy with the whole true falses, your test points. So communicate this answer. It goes from negative 2, parenthesis negative 2 to 2, parenthesis. Wait. Okay. Oh my gosh. Let's try 360. Number 360. 6 over 3x squared minus 2x minus 5. Greater than or equal to 0. Okay, hopefully the bottom factors. You try the x method. I'm going to do guess and check. 5, 1, negative 5x, plus 3 of them, negative 2. Okay, so if I set each piece equal to 0, set this equal to 0, that's 5/3. Set this equal to 0, that's minus 1. So if I'm drawing a number line, 0's here, negative 1 there, 5/3. So 5/3 is some positive number. It's between 1 and 2, right? 5/3 is like 1 and 2/3. So your picture doesn't need to be great. 5/3. You just kind of, so off to the side, I know that that's 1 1/3. Maybe put that there. And those are both on bottom, so open circle, right? Wherever the bottom equals 0, you need open circles. Now let's look at the top. Where's the top 0? Oh, it's just a 6. Oh, sweet. I don't have to do anything. It's never going to be 0. It's always 6. Cool. So now, here's my areas. This area, that area, that area. Let's plug in 0. So if I plug in 0, that's 6. That goes to 0. That goes to 0. 6 over minus 5 is a negative number. 6 over minus 5 is a negative number. Is a negative number greater than or equal to 0? No. False. So I'm assuming it's going to be true and true. Let's find out. Let's plug in a number over here. So that's 1 1/3. So we can plug in 2. I'll plug in 2. Let's see what happens. So you get 6 on top, obviously. And then if I plug in 2, 3 times 2 squared, 3 times 4 is 12, minus 4 minus 5. That's minus 9, so that's 6 over 3, which is 2, which is positive, which is greater than 0. True. Let's try a negative 2, plugging it in. So that's 6 over, let's see, 3 times negative 2 squared. Negative 2 squared is 4, so that's 12. Negative 2, plus 4, minus 5. 16 minus 5, so 6/9. Is 6/9 greater than 0? Yes. True. Okay, so now we have our picture. Let's describe where it's true. So from negative infinity all the way to negative 1, open circle, parenthesis, parenthesis. Infinities always get parenthesis. Union, and then from 5/3 all the way to infinity. All right, this is totally making sense. Let's try 366. 366, and then we'll be done with 66. I think, let me take a peek down there. Function. Oh, yeah. Easy. 366. 1/2 minus 3 over 2x squared greater than or equal to 1 over x. We need the right side to be 0. 1/2. The minus 1 over x. I'm going to put it in the middle here for a second. Just because I see the order. So now I look at the bottom, 2x squared. So remember, get the lowest common denominator, which is 2x squared. So this guy needs an x squared, so multiply by x squared over x squared. This guy needs a 2x, so multiply by 2x. And this guy is good. So we have x squared minus 2x minus 3 all over 2x squared greater than or equal to 0. Oh my gosh. How are we doing so far, folks? Let's factor this top. X, negative 3, positive 1. Okay. So now, let's see how we're doing. 0, 1, 2, 3, 4. 1, 2, 3, 4. So, looking at this mess right here, this is factored here, so everything's in factor form. First thing we do is we look at the bottom. So the open circles, whenever the bottom's equal to 0. When is the bottom equal to 0? Oh, it's 2x squared. See how it's just an x or an x squared? So it's not like a binomial, so it's real easy. So 0. So the bottom becomes 0 when x is 0. Open 0. So just set the bottom equal to 0. You'll solve that x is 0. And then how about the top? Open circles or closed circles? Oh, it's the or equal to, so closed circles. So at positive 3, closed circle, and at negative 1, because you set each piece equal to 0. So now, there's this area, there's that little area, there's this area, and that area. Oh my gosh, there's 4 areas. No big deal. Okay, let's try something between 0 and 3. I'm going to put my notes right here. Let's try 1. 1 minus 3 is negative 2. 1 plus 1 is 2. And then on bottom, 1 squared is 1 is 2. And then I don't really need to figure it out exactly. I know that this is negative, right? So just keep track of negative signs. This answer is negative. Is negative greater than or equal to 0? No. So this whole area is false. Let's try a number bigger than 3. Let's try like 4. So I'm plugging into the factored form, by the way. It's easier. So if I plug in 4, 4 minus 3 is 1. 4 plus 1 is 5. And then 2 times 4 squared. 2 times 4 squared. You don't really need to figure it out. You see how this is positive? Is positive greater than 0? Yes, true. Could you figure it out? Oh, it's 5 over 32. Okay, cool. That's still more than 0. True. Okay. I'm going to have to pick like negative 1/2. Good gosh. So now it's tricky. Negative 1/2. So negative 1/2. So watch what I do here. Negative 1/2 minus 3 is negative. Negative 1/2 plus 1, that's positive. Negative 1/2 squared is positive times 2 is positive. So I don't even care what the numbers are. It's going to be a negative times a positive, which is negative. Is a negative greater than 0? No. False. And then let's pick a number. I know this probably bugged you. But go ahead and plug in negative 1/2 into this, and you can actually figure it out for sure. But I was trying to show you my shortcut. So negative 2. You could actually just plug negative 2 in here, 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 and figure it out. But I'm going to use my lazy shortcut. Negative 2. Negative 2 minus 3 is negative. Negative 2 plus 1 is negative. Negative 2 squared is positive. Times 2 is positive. Negative times negative is positive. So this whole thing is just positive. Is positive greater than or equal to 0? Yes. True. Okay. So the answer is from here to here and there to there. So from negative infinity to negative 1, inclusive on the negative 1, union, nothing, 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 bracket, 3, infinity parenthesis. Whew. Is that right? To negative 1, bracket, and then bracket 3 to infinity. Okay, so you should be able to handle all of 7.6 now. Yay!